Lesson 5.4. The main difference between this lesson and the previous one is that this one is on a unit circle, which means that, let's say this is a circle, this is our point, the radius will always be 1. So our r is always 1. This will always be 1. So anywhere in our previous lesson where we had r, we'll just replace that by 1. So here it will be y over 1, y. This will be x over 1, which will be x. This will stay the same, y over x. This will be 1 over y. This will be 1 over x. This will be x over y. This lesson also, sine of theta is equal to sine t. They mean the same thing. Let's start with an exercise. Identify the ordered pair on the unit circle corresponding to each real number t. So when they say ordered pair, they mean x and y. When they say unit circle, they mean radius equal 1, t is equal to theta. So in the previous rules we just mentioned, we wrote that sine of t or theta is equal to y over r, but since r is equal to 1, so it's just equal to y. And cosine of t is equal to x over r, but because it's a unit circle, it's x over 1, which equals to x. So we can replace x and y by sine or cosine t, comma, sine t. Now we just replace t by 5 pi over 3. Sine 5 pi over 3, comma, sine 5 pi over 3. Now you just use a calculator. So cosine 5 pi over 3 is 1 over 2. And sine 5 pi over 3 is negative radical 3 over 2. That's our ordered pair. Let's solve another one. So here again, identify the ordered pairs. So it's x and y on the unit circle, so the radius is 1 to each real number t. So sine of t is y, sine of t is x, so it's cosine of 7 pi over 6, comma, sine of 7 pi over 6. Just use a calculator. Sine of 7 pi over 6, negative radical 3 over 2, comma, sine 7 pi over 6. It's negative 1 over 2. That's our answer. On to the next type of question. Here you just substitute and place it in the calculator. So evaluate the trigonometric function at the given real number. So it will be g of t to sine 5 pi over 4. Bring the calculator. Make sure it's in radian. Sine 5 pi over 4. Negative radical 2 over 2. So g of t equal to negative radical 2 over 2. That's our answer. Okay, let's do another one. Evaluate the trigonometric function at the given real number. So we just substitute, so z of t equal to cosecant 7 pi over 4. So z of t is equal to, since it's an inverse function, or reciprocal function rather, we do 1 over the reciprocal function of the reciprocal. 1 over sine 7 pi over 4. That's negative radical 2. On to the next type of question. Use the periodic properties of the trigonometric functions to simplify each expression to a single function of t. Now let's recap on what were the periodic properties. So we had periods that had 2 pi. We had functions with periods that had pi. The functions of period that had 2 pi are sine, cosine, secant, cosecant, secant. The periods with pi, tan and cotan. Since sine t plus 2 pi, since 2 pi is the period, the 2 pi just goes away. Sine t, so it becomes sine t. Then cotan is plus its period, so the period goes away. It's cotan t. Then we simplify cotan into sine and cosine. So tan is equal to sine over cosine. So cotan would be the reciprocal of that. It would be cosine over sine. So sine t, cosine over sine. Sine and sine go away, so the answer is cosine t. Okay, let's do another one. So this time we have tan t plus pi and cosecant t plus 2 pi. So tan is plus its period, so the period goes away. Then cosecant is plus its period, so the period goes away. And here we have to simplify it to a single function of t. So we separate these into sine and cosine. So tan is sine over cosine times cosecant is 1 over sine. Sine and sine go away. It's 1 over cosine to secant. On to the next question. We have to use both the even, odd, and the periodic properties to simplify. So let's recap on what were the even and odd properties. So we had odd, so the even were the cosine and its reciprocal, the secant. The odd were everything else. So here, nothing to simplify here. Cosecant is odd, but we can't really do anything about it. Then we have minus 4 cosecant of negative theta. Here we cannot subtract them because they don't have the same inner value of the parentheses. But since the cosecant is odd, we can take this negative here and throw it outside. So it becomes cosecant theta minus or plus 4 cosecant of theta. So it becomes 5 cosecant theta. On to the next one. We have negative cotan of negative theta plus pi minus cotan of theta. Here we cannot simplify anything, so we go to the next one, or the first one. Here cotan is added to its period, so the period can just disappear. Cotan negative theta is cotan of theta. Here we cannot subtract them because they don't have the same inner parenthesis value. So since cotan is a odd function, the negative will go outside. So plus cotan theta minus cotan theta. So the answer is 0. This is a positive sign, so we can just remove it. Okay, let's do another one, but this time we have an even function. So cosine of negative 2 theta minus cosine of 2 theta. We cannot subtract them because they do not have the same inner parenthesis value. Since cosine is an even function, this negative will just disappear. It will not go outside. So it becomes cosine of 2 theta minus cosine of 2 theta, which equals to 0. So here we're given a value of cosine and we're asked to evaluate it in different forms. So let's look at A. So A has cosine of negative t, but since cosine is an even function, the negative just disappears. So it becomes cosine of t. Cosine of t is negative 3 over 4. So cosine of t minus 2 pi. Minus 2 pi has the same effect as plus 2 pi since it's the same period, which is 2 pi. Since the period is 2 pi, it just disappears. Cosine of t, which is equal to negative 3 over 4. Then for the last one, we have minus 2 pi, so it just disappears. Then negative secant negative t. Now secant is the reciprocal of cosine. Cosine is an even function, so the negative just disappears. Secant of t. Since we don't have the value of secant of t, we have to write it as 1 over cosine of t, which equals to 1 over negative 3 over 4, which equals to negative 4 over 3. On to the last question we have for this lesson. Write tan in terms of secant. So when we have questions like this, we will usually use one of the 3 identity rules. So I'll just write them. We have sine squared plus cosine squared, 1, then 1 plus tan squared equals secant squared, 1 plus cotan squared is equal to cosecant squared. So write tan in terms of secant, so we're going to use the second one here. So write tan in terms of secant, so we have to isolate tan. So tan squared x to secant squared x minus 1, then radical both sides, so tan is equal to plus minus radical secant squared x minus 1. Since it's in quadrant 2, we know that we know that tan is negative in quadrant 2, so we take the negative. It's negative radical secant squared x minus 1, and in quadrant 4 tan is also negative, so we're going to take the negative. So even in quadrant 4, tan is equal to negative radical secant squared minus 1. If they asked in quadrant 3 or 1, then we'd put plus radical secant squared minus 1.